Hi, the Science Chef is here again. In this video, we'll be answering question 1 of the October-November 2019 Cambridge IGCSE Chemistry Paper 4. If you'd like to watch our complete solutions to the May June 2020 Paper 4, check the links in the description. Also, you can join our membership club to gain access to exclusive videos, live chats, and live tutorials, where you can ask questions on any challenging topics in chemistry. Question 1. Question 1 says the periodic table is very useful to chemists. Let's underline the keyword there. The periodic what? Table, which means that this question will be based on what? The periodic what? Table, right? Now refer only to elements with atomic numbers 1 to 36 in the periodic table provided when answering question what? 1. Use information from the periodic table provided to identify one element which has atoms with exactly 9 protons. Now, since this question is on the periodic table, then we need to use a periodic what? Table. So, what is a periodic table? A periodic table is a tabular arrangement of elements in rows and columns in order of their increasing what? Atomic numbers. The rows, which are numbered 1 to 7, are called the periods, while the columns which are numbered 1 to 8 are called the groups. So you have, these are the rows, this period 1, this period 2, this period 3, period 4, that's row 4, period 5, period 6, and period 7. So you have group 1, group 2, as you can see here, group 1, group 2 to what? Group 8. This is group 8 here, right? Or group 0. Now, what is significant about the groups and the periods? The group number represents the number of what? Valence electrons in the outermost shell of the atom of an element, while the period number represents what? The number of what? Shells. The number of shells in the atom of an element, right? Now, elements in the same group have the same number of what? Valence electrons, and they exhibit similar what? Chemical properties. Why? Because it is the valence electrons that determine the chemical properties of the atom of an element, or the number of valence electrons that determine the chemical properties of what? Of an atom or an element. Then, while the number of shells, right? Elements in the same period have the same number of what? Shells. As you move across the period from left to right, you move away from metals to what? Non-metals, which means that the metallic characters decrease as you move from left to right, while the non-metallic characters increase as you move from left to right. Fine, having that knowledge now, let's go back to our question. So, use information from the periodic table provided to identify one element which has atoms with exactly 9 protons. Now, for it to have exactly 9 protons, remember the keyword is what? Atoms, which that is what? Neutral, right? And has what? 9 protons. Remember, the elements are arranged in order of increasing what? Atomic what? Number. An atomic number is the same. Atomic number is the same as what? Number of protons. Number of protons in the nucleus. In the nucleus of an atom. Right? Which means that the element whose atom has exactly 9 protons must have an atomic number of what? 9. So let's go to the periodic table and look for elements with atomic number what? 9. Now, on this periodic table, we see that each element has what? 2 numbers. Now, from the key given here, the number on the top is the what? Atomic number, which is the number of protons in the nucleus of the element, while the one below is the what? Relative atomic what? Mass, or the nucleon what? Number of the atom, right? Of the element. Fine. So, from this, the element with atomic number 9 is what? Fluorine. So, our answer is what? Fluorine. Fluorine. You can write the name and what? The symbol, to be on the safer side. Has atoms with 0 neutrons. Has atoms, the keyword here is what? Atoms with what? 0 neutrons. Now for it to have 0 neutrons, remember in our previous tutorial we said that the nuclear number or mass number of an atom is equals to what? The number of protons plus what? Number of what? Neutrons, is it not? Right? A number of protons is the same thing as what? Atomic what? Number. Which means that for this element to have 0 neutrons, its mass number will be the same as its what? Atomic number, or its nuclear number will be the same as its what? Atomic number. So if you go to the periodic table, the only element here whose atomic number is the same as its nuclear number or mass number or relative atomic mass is what? Hydrogen. You can see in other elements, their relative atomic masses or the mass numbers or the nuclear numbers are higher than their proton what? Numbers or atomic numbers, because the nuclear number also includes the number of what? Number of neutrons in the nucleus of the what? Atom, right? But for hydrogen, since hydrogen has no neutron, then its mass number is the same as its what? Atomic what? Number, which is 1, 1. Note that hydrogen 1, H11, which is also known as what? Protium, or ordinary what? Hydrogen, or ordinary hydrogen, is the only element, is the only atom with what? With an incomplete set of what? Subatomic what? Particles, because here it has 1 proton, it has 1 electron since it is an atom, but it has no what? Neutron. It has no neutron. So whereas every other element in the periodic table has what? At least 1 neutron in the nucleus of its what? Atom. So hydrogen is the only element with an incomplete set of what? Subatomic what? Particles. Alright, so let's move. Element which has atoms with exactly 23 what? Electrons. Atoms. Whenever you're talking about atoms, it means that you're talking about what? Neutral what? Particles, right? With exactly 23 what? Electrons. Which means that for it to be neutral, the number of protons for a neutral atom, number of protons equals to what? Number of what? Electrons, right? Number of protons equals to what? Number of electrons. So since it has exactly 23 electrons and it is an atom, it means that its atomic number is also what? 23, because its number of protons will be what? 23. So let's go and look for element with atomic number what? 23. At least you are familiar with the first 20 elements, from hydrogen to what? Calcium, which is 20. So scandium 21, titanium 22, vanadium what? 23. So answer is what? Vanadium. Answer is vanadium. That's what V. Okay, we move. Has atoms with an electronic structure of what? 286. Atoms with an electronic structure of what? 286. Now electronic configuration is based on what? The number of what? Electrons in the atom of the element. That's the way the atoms are what? Arranged. So if the electronic configuration is what? 286, it means the total number of electrons in the atom is what? 16 what? Electrons, right? And since it is an atom, it means that it is a neutral what? Particle, and the number of electrons is the same as the what? Number of what? Protons. So if the number of protons is also what? 16, it means that the atomic number is what? 16. So which element has atomic number what? 16. Also from the electronic configuration 286, we can see that the element has what? 3 shells. That's what? Period. It will be in what period? What? 3. 1, 2, 3. 3 shells, and the valence electron is what? 6. So period 3, group what? 6. So each element is in period 3, group 6, or has an atomic number what? 16. Let's see. Period 3. Yes, group 6. That is what? Sulfur. Does it have atomic number 16? Yes, it does. So answer is what? Sulfur. That's what? S. forms ions with a charge of what? -3 or 3 minus, containing 18 electrons. The keywords here, ions, right? With a charge of 3 minus, containing what? 18 electrons. Now, for it to form a negative charge, right? Charge of minus means that it is what? A non-metal that has what? Gained electrons, right? A non-metal gains electrons, right? So it has gained 3 electrons to form what? An ion with a charge of what? -3, right? Now, but for us to locate that element on the periodic table, we need to know its what? Atomic number. And the atomic number of an element does not change. In other words, the number of protons does not change, but it is the number of electrons that normally what? Changes, right? Which is responsible for the what? For the charge. So now, how can we now get the original number of what? Protons of the element? We use a formula: Q, charge, equals to what? Number of protons minus number of what? Electrons, right? We are looking for number of protons. So number of protons here be equal to what? Charge minus what? Number of electrons. What's that charge? A charge is -3. What's the total number of electrons there? 18. That's plus 18. That gives us what? 15 plus 15, right? So which means that the number of protons in the atom or in the ions will be what? 15, right? So the atomic number of that element will be what? 15. So which element has an atomic number what? 15. The last question was the element atomic number 16. So the next one, the one before it should be what? Phosphorus, which has atomic number what? 15. So the answer is phosphorus. Phosphorus. That's what? B. Alright. Now, the next question says forms ions with a charge of what? +2 and 10 electrons. Charge of +2. Now it means that it's now forming what? A positive what? Ion with +2. And positive ions are metallic what? Ions. And metals ionized by what? The loss of what? Electrons. Which means that it must have had more electrons than the ion currently what? Has, right? And to calculate the charge, of course, using our formula, the charge here will be what? The number of protons. We need to know the number of protons in order to locate it on the periodic what? Table. Number of protons will be what? +2, right? Plus the number of electrons, which is what? 10. That's based on this formula. This is our formula here, right? +2 plus 10, which gives us what? 12, right? So it means that the element with atomic number 12 would be the answer. That is what? Magnesium. Good. Magnesium. Magnesium. That's Mg. Next question says, has a relative atomic mass that shows it has at least 2 what? Isotopes. Now, if an element has at least 2 isotopes, its relative atomic mass will not be a whole number, right? Actually, all elements exhibit what? Isotopy. Means that all elements are made up of what? Isotopes. But that of chlorine is very what? Obvious. Because while the relative atomic masses of other elements can be easily approximated to the nearest whole number, it is difficult to do that for what? Chlorine. That's why on the periodic table, it is only chlorine that has a relative atomic mass that's what? A fraction, right? That's what? A decimal. So let's check whether we are what? Correct. The relative atomic mass of chlorine is about 35.5. So let's see. Where is it? 35.5. Yes, which is due to the relative abundance of the 2 isotopes of chlorine. Chlorine 35 and what? Chlorine what? 37. This one is 75%. This one is what? 25 what? Percent, right? Let's write the answer first. Chlorine. That's what? Cl. If you actually want to learn more about isotopy and how to calculate the relative atomic masses of elements that contain what? Isotopes, right? You will watch our video on isotopy. We've added the links in the description. Alright, so we are done with question 1A. Question 1B says, state which metal in the first 36 elements. State which metal. The operating word there is what? Metal. Metal. We are looking at metal now. In the first 36 elements is the group 1 element which reacts what most vigorously with what? Water. Now the reaction with cold water, the vigorous reaction with cold water, is a typical chemical property of group 1 what? Metals. They react vigorously with what? Cold water, right, to form what? Alkalis and liberate what? Hydrogen what? Gas, which is why they are called alkali what? Metals. So we are now asked to find the group 1 element that reacts most vigorously with what? Water among the first 36 what? Elements. First off, let's go to the periodic table and check the first 36 element. The first 36 element starts from what? Hydrogen, and ends at what? This is 30, 20, 21, 22, 23, 24, 25, 30 to 36. So that ends at what? Krypton. So that's where our focus shall be, from hydrogen to what? Krypton, right? Based on our reference area, right, we have 3 metals in what? Group 1: lithium, sodium, and what? Potassium. And since the reactivity of metals decreases down the group, means that lithium will be what? The least reactive in group 1, while potassium, based on our reference, will be what? The most reactive. So potassium is the element in group 1 that will do what? That will react most vigorously with what? Water. In fact, potassium does not just react vigorously with water, it reacts what? Violently, because it bursts into what? Flames in cold water. So the answer is what? Potassium. Please note that potassium is not the most reactive element in group 1, right? We still have rubidium, we also have what? Cesium here, right? Francium is what? Radioactive, and it's not what? Stable. So most times it is not always used in the analysis of the properties of what? Group 1 what? Element, because it has not been what? Fully what? Isolated. So its properties are always what? Predicted using what? The existing what? Elements. That's from lithium to cesium. So because of that, cesium is always considered as the what? Most reactive group 1 what? Element. Based on this question, our answer is what? Potassium. So the next question says the metal that reacts with what? Air to form what? Lime, based on our reference. So when you say lime, the first thing that will come to your mind is what? Calcium in chemistry. So metal that reacts with air. So if calcium reacts with what? Air, it forms what? Calcium what? Oxide, is it not? And calcium oxide is known as what? Quick what? Lime. Calcium oxide is known as what? Quick lime, or simply what? Lime, right? Fine. And when a little amount of water is added to it, partly dissolved to form lime water, right? And what? Slate what? Lime. So the answer is what? Calcium. Calcium. That's what? Ca. Right? So question C, we're done with question B. Question 1C says one element in the first 36 elements is used as the fuel in a fuel cell. Name this element. Now the elements commonly used as a fuel in a fuel cell is what? Is hydrogen what? Gas, right? It's hydrogen what? Gas, because it burns in oxygen to generate what? A lot of what? Heat energy, and the byproduct is environmentally what? Friendly. The byproduct does not pollute the environment, right? As we will see later. So the answer is what? Hydrogen. It's light and very effective or efficient as a what? As a fuel. So just like it is what? Expensive. So the answer is here. Answer here is what? Hydrogen. Okay, the last question here says write the overall chemical equation for the reaction which occurs when the element in C1 above reacts in a what? Fuel cell. Of course, for it to react in a fuel cell, it must undergo what? Combustion in the presence of what? Oxygen. So when hydrogen undergoes combustion in the presence of what? Oxygen. In the presence of oxygen, what do we expect to get? Get what? Water. So we balance this and we balance this. So that is what? the overall chemical equation for the reaction which occurs when the elements in Ci reacts in a fuel cell, right? So that's why the fuel cell is said to be environmentally friendly, because it does not contribute to the pollution of the environment. Its product is just water, unlike fossil fuels that will produce CO2, that will pollute the environment, or not necessarily pollute the environment, that will bring about greenhouse effect, and which leads to global warming, right? That is it. That brings us to the end of the solution to the question 1 of the October-November 2019 Cambridge IGCSE Chemistry Paper 4. If you have any question on our solution so far, if there's anything you don't understand, please don't hesitate to drop your questions in the comment section. I can assure you we'll attend to it expressly. So if you learned anything from this tutorial, hit the like button, and if this is your first time here, subscribe to our channel and turn on the notification bell to always stay updated with our new uploads. A wise man once said, "The past is my heritage, the present is my responsibility, and the future is my challenge." So stop dwelling in your past and keep working hard to create the future you desire. Till I see you when I'll see you.